Alrighty, so practice test, we are off. So we'll go through this and then we'll reach a conclusion as to whether you want to re-practice a part of this, which we could do, or if you're feeling test ready, which we can do, but more on that to be determined. First, let's go quick vocab. If you need a ton of vocab answers, just watch the video from 9.10b. But friendly neighborhood reminder, 1 had a bonus point, 9 has a bonus point, 52 to 55 has like a triple bonus point. Does anybody need anything about any of that? Up to 55ers. Quick and easy. 56, what does make a compound be an oxide? Tell me. Oxygen is in it. What makes you have a base? OH is in it. Anything through to the end of that page? Then on the next page, it seems like this year I neglected to hand out a handout. Maybe we were at remote time this year because of the cold, or I don't know what happened, but usually at the beginning of Chapter 9, I hand out a paper that says Chapter 9, Helpful Hints. And a lot of the answers that we're about to do are what is usually on that sheet. So 7 diatomic, and it's all old stuff. It's old stuff from other chapters that has lived on. So 58 to 64, our diatomic friends are ION, HF, CL, and BR in no particular order. There's 7 of them. I don't care if you write the 2s on that list or not, but I do care that you write the 2s when we get to the balancing problems later on. 65 is hydrogen and ATEs become IC in naming acids, like sulfate becomes sulfuric, for example. 67, ITE is what goes with OUS acids, so like sulfite would become sulfurous. 68 is 1 atom, hence the prefix mono. Those names end in "ide," and we find their charges by Roman numerals on the periodic table. I'd rather say Roman numerals on the periodic table there than just say periodic table. Polyatomic are the ones you hate more. Those have 2 or more atoms, and the only way to know their charge is to memorize them. Then we're filling in the symbols, and the sheet that I just finally handed you from that handout, the helpful hints, it has all of those on it and in the same order. To help your memorizing, one tidbit of help, there's only 1 with 3 minus, that's phosphate. There's 6 with 2 minuses, which are the 2 sulfurs, the 2 chromiums, and the 2 carbons. Everybody else has a charge of -1, except ammonium is the only one that has a positive charge. In terms of oxygen counts, the 8s usually have how many oxygens? Usually 4, but not universally. Anybody need any more than that from me to handle that group? And then we see if we can still write correct formulas. Next chapter we'll still need this. This chapter we needed this. A previous chapter we needed this. This is part of our past, present, and future. So potassium oxide is K2O. The reason the 2 is there, because if you check the periodic table, oxygen has a charge of 2, but potassium only has a charge of 1, and you need to bring those into balance with the switches to make the subscripts. Second one is MgCl2. That 2 exists for the same reason that magnesium's charge is 2 and chlorine's only 1, so switch it. Then there's a BaS where the charges match, so we're good with no subscripts. Aluminum has a 3 charge, oxygen has a 2, so a little switch for Al2O3. And then we get into ones where we start to have to memorize. Not lithium, that's periodic table, charge of 1. Carbonate, CO3, has a charge of 2, so subscript, we need an Li2CO3. Anybody need help to 103? 104, we continue that game. Magnesium is Mg, and that has a charge of 2. Nitrate is NO2, but we need to wrap NO2 up in parentheses and put a 2 subscript after the parentheses because magnesium's charge of 2 and nitrate only had a charge of 1. We need subscript to play. Sodium only has a charge of 1, and phosphate is our only friend with 3 of the memory ones. So that's Na3PO4. Calcium is a good fit with sulfate, Ca, and then SO4. Just go fit nicely together. And then I go into stuff that involves the nonmetals, which we have to have those prefixes still in our mind. The di, tri, tetra, all of those. There's 10 of them. So the first one here is N2O5. The second one is PS3. Does anybody need help with that little groupie group? 104, phosphoric. We need to think about phosphate because ic goes with 8. So phosphate, we need a PO4 involved. And then every acid starts with H. But H only has a charge of 1 and phosphate has a charge of 3. So we need to go H3PO4. Sulfuric acid, you might want to consider just memorizing that it's H2SO4. Once upon a time we did memorize that when we did the marble, lye, chalk, all that stuff on that one handout. If you didn't memorize it, it's fine. The ic trades for an 8, sulfate, SO4. You need H2 to balance out the SO4. Hydro is a prefix that means that the acid is binary. So just HCl works and the charges are good. Acetic is acetate at its heart. So we grab C2H3O2 from our acetate list and just throw an H in front of that. So HC2H3O2. Carbonic would be based on carbonate, which is CO3, which has a charge of 2. So we need H2, CO3. And the last time we took a test, we struggled at naming acids. I offered a retest. A couple people did it, but most people just kind of left it how it had been. The rules haven't changed. I don't know if our knowledge has improved, but I do have a little bit of concern over the naming acids group right now. Anybody 104 to 8 want me to run that back? Acid-base salt, we also struggled with on that test, and there was no need to struggle on that. I think the issue potentially was, I think we took this test the day before Christmas. I think we went a little bit fast-forwardy this year to try to get the test in before Christmas. And I don't know that people were prepped for the test so much as they were on, Christmas mode. But this first one is an absolute definite acid. What gives that away completely? The H in the start. So start with H, that's an acid, that's easy. Second one has a dead giveaway.
It's a base.
It's a base because the OH at the back. And since the third one doesn't have either of those giveaways, it's a salt. And that fourth one is a salt. There's no reason to miss those ever, but we did. But life has gone on and we've survived. But you want to crush that group. There's no reason to miss anything there. Anything to 112. 113 to 20, we're not going to balance some. I don't think they are balanced. They just sort of are there. But we're just trying to identify what they are. So first one, easy identification, decomposition. Because you have one thing turning into two. Are there any more decompositions? No. That's the only one. Second one I'm going to skip for a second. Third one is a giveaway combination. What gives that away?
Two things become one.
Two things became one. So dead giveaway on combination third one. Skip the fourth one for a second. Fifth one has a giveaway.
H2O turning into
No, different giveaway.
Single replacement. 'Cause it's
Single replacement. What gives away single replacement?
Like the one thing on the compound.
Yeah, who's the giveaway element on that fifth one? The solo artist.
I think that's
Calcium. Calcium was a solo artist plus a compound. Then calcium joins forces with somebody else, and hydrogen's a solo artist. So if you're trading, who is the solo artist while they like trade into the compound? That's single replacement. There is another single replacement,
the last one.
which is the last one. So what we have so far is decomposition, skip, combination, skip, single replacement, skip, skip, single replacement. It's easier to spot the single replacements, the decompositions, and the combinations. The other two are tricky. Question about those? Okay, the other ones look about the same. The double replacement looks about like the neutralization does. If you want a fairly likely way to tell the difference, what's a fairly likely way?
Neutralization makes water.
Neutralization frequently makes water, but I won't say always, but I'll say frequently. So if you want a quick thing that will work a lot of the time, that can work for you. If you want a surefire thing that will work, what you need to do on vocabulary 52 to 55 is know vocabulary 52 to 55 and be on the lookout for those four types. So this second one is a neutralization, because what you have is an acid plus a a metal oxide. So acid plus metal oxide, that is one of those four choices on 52 to 54. If you just trusted the water rule, you'd have been okay, because it did make water. The fourth one is a double replacement, because it doesn't fit any of those formats. It doesn't produce water. But if we look at this, neither of these things is an acid or a base or an oxide. So if you see no acids or bases or oxides, there's no way that's neutralization. Neutralization is some combination of acids, bases, and oxides. Without those, definite double replacement. So 3 from the bottom is a double replacement. Water lets you down there. So if you saw the water on the right, you're like, neutralization, that's not an always, that's an often rule. If you look to the left, you have no, you do have an acid, HCl, but you don't have a base or an oxide to be its partner. So that is a double replacement. The almost bottom, second to bottom, that one is a neutralization. It is a definite acid plus a definite base. That's the easiest neutralization to probably remember. You did get water, so the water thing would have gotten you 3 out of 4, but knowing the 52 to 55 vocabulary is the only way to guarantee you get 4 out of 4 on that. So one more run through: decomposition, neutralization, combination, double replace, single replace, double replace, neutralization, single replace. That would be a day worth of test. That's usually the first day worth of test we do when we get to a day of test. If you're feeling dicey on the stuff that went from like 56 to the end, I have a spare sheet that we could do before we do the test. This would be a tomorrow project that runs you back through the stuff for basically from 56 to the end types of things. You don't have to fill in the table of ions again, but it's writing the formulas for the acids, writing formulas for stuff. No, you do have to fill in the ions. I take that back. So it's most of this skills from some of that stuff. We could hit up a day of that, but it doesn't cover all of the topics. It covers, I think, 56 to like 108. It doesn't do anything with the 109 at the bottoms again. It's like a mini sheet. So we'll go vote on that in a minute once we're done recording and just decide how people are feeling about those. Question before we turn the page to the test, other part, the balancing part. Okay, so the balancing part of this sheet I did not create one new example. What I did is I just plagiarized from like homework directly. I just lifted ones you have already done before. So if you have any of these that you're like, I can't do this, then you probably lied about your homework or tried to fake me out, because you have done all of these. On the test, you will have done all of them. I'm just ripping off stuff straight from the book and like mixing them up into whatever order I mix them up. So, I don't know. These will be 3 points apiece. You either get them or you don't. The second page is going to obviously, well, starting at 6 is definitely the hardest part, from 6 to 20. But here we go. 1 to 5 in terms of coefficients. I've got empty space 6 and 4. Number 2, I have empty space 4, empty space 5. For number 3, it's 3, 2, empty, 3, 3. 4 is 6, empty, and 4. 5 is 3, 4, 2, 3. Does anybody need help to balance? 1 to 5. Six is going to be a pain to write the formulas, and if you're not good at writing the formulas from our earlier chapter skills, that's going to rock you. If you can write the formulas, then this is not, once written, any harder than 1 to 5. It's just likelihood of error because you had to write your own formula. So here's what I got with CaI2 from charge, periodic table, calcium has a charge of 2, so I2, plus H2SO4. I'll say yields instead of saying arrow, because that's like what you're supposed to say. 2HI plus CaSO4. 7, to balance, I have a 2 Hg plus an O2, because it's diatomic. If you don't have the O2 diatomic recognized, it just wrecks the whole process. Yields a 2 to balance it, HgO. The charges are all good there, so we don't need subscripts on the HgO. 8 is Mg, and then in parentheses Cn, and after the parentheses a 2 to balance magnesium's charge of 2, plus a 2 HCl, yields a 2 HCN plus an MgCl2. It's a Cl2 because the charge on magnesium's a 2, and we need to equal that out. 9 is an Al2, and then in parentheses SO4, and when the parentheses end, a 3 to balance charges between aluminum's 3 and sulfate's 2, plus 6 NaOH. No parentheses or subscripts needed there because Na and OH are both in the 1 charge family. Yields 2 to balance Al, then parentheses around OH with a little 3 after the parentheses to make aluminum's charge of 3 have a friend, plus a 3 Na2. Na has a 2 to make the charges match for SO4. So that last piece is 3 Na2 SO4. 10, I have Ba, and then parentheses around NO3 with a little 2 after the parentheses to make barium's charge of 2 be okay, plus the H2SO4 that I'd suggest you just memorize and not have to think through every time you see sulfuric acid. Yields BaSO4, charges are okay there, plus a 2 HNO3. What can I help with there other than that little bit of gentle guidance I gave as I wrote them for you? Anything? Okay. 11. Let's go to the right first. No, I'll work from left to right. Never mind. I'll just do both things at once. So 11 is a 2Al plus 6 HCl. And then after the arrow, a 2AlCl3. The Cl has a 3 because of aluminum's charge. Plus a 3H2. H has a 2 because it's diatomic. And you don't have to label anything there. You only have to label the solids and gases for the neutralization of the double replacement. If that was a single replacement, you don't have to label anything. 12, there's no reaction. I'd give you a copy of the electromotive series. Copper is not attractive enough, high enough on that list to replace Fe. Fe is higher on the list, so Fe just sits. So you can't crowd that out. So just write no reaction and move down. 13 is going to have a 2 AgNO3 plus, leave the second one alone. After the arrow, there's an Ag with a little 2 and an S, and that's labeled as a solid, plus a 2 HNO3. 14, leave the first one alone, plus 2 of that acid. After the arrow, there's 2 NaC2H3O2 plus, split up the, don't write it as like a HCO3 kind of thing. That splits up to H2O, which you don't have to label, plus CO2, which is a gas. 15, leave the first one alone, plus 2 of the second one. After the arrow, it's Zn in parentheses, NO3, little 2 after the parentheses, plus 2 H2Os. 16, 3 of the SO3s, plus 2 of the Fe thing. After the arrow, it's Fe2, and then in parentheses SO4, and after the parentheses end, a little 3, plus 3 H2O. 17, Hg is lower on the list than Pb, so Pb cuts in. It's PbBr2 plus Hg. 18, leave the first CO2 unlabeled, put a 2 on NaOH. After the arrow, it's Na little 2 CO3 plus H2O. And we're pretty lucky on this. We haven't labeled too much because almost everything was soluble. So the only insoluble thing we got was 13. So this might be just a lucky sheet. 19, I spoke too soon. 19 is going to have a solid labeled. The left is already balanced fine. On the right, it's SNS, which is labeled as a solid because that is insoluble, plus a 2 HCl. And then 20 is already balanced just fine, and it's FeSO4 plus 2 things because that HCO3 stuff falls apart into H2O plus CO2, and we'll label CO2 as a gas. I don't know how you like to work. If you like to do hard things first and then have it get easy, start with that page. If you'd rather do easy stuff first and then work your way up to the hard, do this page last. Because this 11 to 20 is absolutely the hardest page. The 21 to 30 is absolutely the easiest page. The first 1 to 10 is absolutely the medium of those pages. So if you want to play with the order and like start off easy and build momentum, feel free. You do what works psychologically the best for you. Anything up to 20 I can do with those hard ones to help make them less hard.
Can you just repeat 16?
16 is 3 SO3 plus 2 of that Fe thing. After the arrow, Fe2, parentheses around SO4 with a little 3, plus 3 H2Os. I can do some stuff on the board, I can talk it out, or whatever. Anybody need anything to 20? Don't be shy.
Can you say what 13 was?
2 of the first Ag thing, and then after the arrow, Ag2S, which is a solid, so S in parentheses, plus a 2 HNO3. Last page, how many were already good? Three. So that's happiness and joy. So we'll reveal them as it goes. 21 goes 2, empty, and 2. 22 is 2. 2, 2, and empty. 23 is already balanced. So just put a big check on it, or put already balanced, or somehow note to me that you know that it's already balanced, because if you leave it empty, I might think you got discouraged and just like shut it down. So mark it somehow as already good, and then I give you your 3. These are 3 points apiece. This part of the test would be 90. 24 has 2, empty, and 2. 25 is empty, 2, empty, and 2. 26 is empty, 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 2. 27 is empty, 2, empty, empty. 28 is 2, 2, and empty. And based on logic and attention spans, that means that the last 2 are already balanced. Anything I can do there?
Say 14.
14 was empty and then 2. After the arrow, a 2, Na, C2, H3, O2, plus an H2O plus a CO2 labeled as gas. When you just do the switch, it creates a temporary like H2CO3, but then our vocabulary question somewhere in the 50s said that can't last, that's gonna fall apart.
Okay.
Anything else I can do with this sheet? If our helpful camera woman could be so kind as to hit the same button, that will stop us.